What is the units digit of the product of any list of 6 consecutive positive integers? Now, if you're this far into math and you know me that well, you're pretty sure that I love to do something stupid all the time before we do the smart thing, that is. So, the stupid thing we're going to do this time is to see, since they said any list of 6 consecutive positive integers, and that this is a list of 6 consecutive positive integers. Well, if it works with any single list, any kind of list that you choose at random for 6 consecutive positive integers, then it works with this list too. So all you have to do is compute the units digit of this list. Well, we first see, 2 times 5 is 10, and 10 ends in 0, and any number ending in 0 times any number ends in 0. That's the units digit of the product. But every time I do something stupid like this, I always like to prove, I love to prove that I'm not that stupid and just move on. I always love to prove that I'm not that stupid and prove my whatever stupid calculation I did that it is right. So you gotta prove that why it ends in 0. Now, we're gonna look at this list of numbers on a number line. See if that will help us. We have 10, 5, okay, how about something that's not that complicated? We just start with 0. Just a regular line. Start at 0, skip count by 5s. Well, if we put the list, we see that we got something ending in 5, and we got an even number, and these two multiply together to get a 10. But is that with every single number? Mark 1 there, where we start. Well, the thing is, I see 5 and 10. Well, any two consecutive multiples of 5, they're all 5 apart. But since they want 6 consecutive positive integers, that means you're going to have to at least include one multiple of 5 in your list. You don't have to include 2 to both 5 and 10, or any two multiples of 5. You don't have to include both of them, but you can't avoid both of them at the same time, meaning that you're going to have a number ending in 5 or a number ending in 10 in your list. Well, if you do have a number ending in 0 in your list, well, then you got a number ending in 0, and 0 times any number, that still ends in 0. So if you have 10 in your list, that'll be pretty easy to see. But if we have an odd number, we also know that there's going to be 3 even numbers in your list, half even, half odd. Well, any even number times any number ending in 5 also ends in 0, and then we have something ending in 0 times something else, which means we're going to have a product that ends in 0. So the thing is here, we can't possibly afford having a number that ends in 0. And just to give that, we can give a little proof here by giving you some examples. Let's take a more complicated list. 4, 5, 6, 4 times 5 times 6 times 7 times 8 times 9. Well, we see we got an even number and we got a number ending in 5. We don't have to, it's not necessary that we need a number that ends in 10. Well, we see that we got an even number and a number ending in 5. When we multiply those together, we get another number that does end in 0. So whenever this stuff comes out, we're gonna have to have a list ending in 0. So now that we proved that 0 is our answer, we can just move on. You proved the stupid thing.